Good morning, good afternoon, or good evening, wherever you are out there, folks. Thank you very much for joining us today on what is the kickoff of the Getting Started with EdgeX Foundry Tech Talk. This Tech Talk series will continue through June. For those who attended last week, we apologize for the technical difficulties. We're hoping not to repeat that performance and have a good session here today. So again, thanks to all that have joined. These recordings will be made available as well through the EdgeX social media and website and wiki, which I'll direct you to a little bit later. But you can find the slides at the bit.ly address you see on the screen right now, bit.ly/EdgeX Tech Talks. So no need to copy down all the material you see. It is available to you already right now through our wiki site. Hello again, everybody. My name is Jim White. I am the IoTech Systems CTO. We're a global edge software company. We provide all sorts of software products, including a commercial implementation of EdgeX Foundry, which we're going to start to discuss here today. Formerly, I was with Dell Technology, and that's where EdgeX Foundry got its origins. We developed that when I was at the IoT platform group inside of Dell in their IoT solution division. EdgeX started back in around 2015 and has since become obviously an open source project under Linux Foundation, which is what we're here to discuss today. Today, I serve as technical steering chairman, and I also am kind of the ad hoc and unofficial lead architect. So it is my job and my duty today to take you through EdgeX Foundry, at least enough to get you started. There's a lot to learn with EdgeX, but our intention here today is to give you enough to kind of get up and running and where to go and get more information. By the way, again, as I mentioned, this is the first of a series of Tech Talk discussions we're going to have over the course of the coming month. So obviously today, here to talk about how you get started with EdgeX. But then as you get started, you're going to want to probably build things that we call application services or device services. Don't worry if you don't know what those mean yet. We're going to talk about those here a little bit today. We'll learn how to build a device profile a little bit later on in the month. And then we'll learn how to get started using the Snap version of EdgeX Foundry provided by Canonical a little bit later on in the month. We may also add some additional Tech Talks through the summer. In fact, we'll talk a little bit about that, and I would be very much interested in hearing from you all. If there's a topic you would like to learn more about, please send us an email, send us a message, and I'll tell you how to do that as we get towards the end of our discussion here today. So again, thanks for joining us, and we hope you join us throughout the month of June to learn more about EdgeX Foundry. Our topic and agenda set today, again, we're going to start by looking a little bit at the background of EdgeX, where it came from, understand a little bit of the architecture, how it works underneath the covers. We're going to talk about the various paths of using or developing or adopting EdgeX. We'll talk about user groups and developer groups, and I'll explain more of that coming up in a bit. We'll talk about the tools you need to work with EdgeX, what types of things you have to have on your system to be able to pull it in and start to use EdgeX or even start to develop with EdgeX. Then we're going to learn how to actually physically get EdgeX, how to run EdgeX. We'll look at how you start to test and explore EdgeX to know that it's operating correctly, to also start to dig in and see how to add things into your EdgeX environment. I'll provide you a few tips and tricks. Those things are a little bit more on the advanced end of working with EdgeX, things that you may not pick up immediately if you just start reading the documentation, but things I find that most people who are using EdgeX would probably like to know a little bit more about as they start to get into it, in particular to help troubleshoot and guide them through maybe some issues that they start to encounter if they're working with EdgeX. Finally, we'll wrap up with where you learn more and some questions and answer period if there is any from our audience as we near the end of our discussion here today. By the way, I have chat open, and I have also the Q&A session open from our Zoom tool here. So feel free throughout the discussion today, drop me a note if you'd like to know a little bit more about a particular topic, or if you have a question in an area, please drop it in the chat or the Q&A section, and we'll do our best to answer. And I got a note already from Carlos, says, can you please share the link to the slides? Again, I'll bring that up here in just a bit, but it's bit.ly/EdgeX Tech Talks, all one word. That'll take you to our wiki site. I'll bring up some of that a little bit later on again. So thanks for your question, Carlos. All right, onward and upward here. And let me get things kind of set up here as I start to display. So first off, what is EdgeX Foundry? Well, open source, vendor neutral project and ecosystem. We're bringing this to you today through the resources of the Linux Foundation, marvelous organization with great people to help us with providing open source technology. EdgeX Foundry is a project inside of Linux Foundation, so it is open source. It is vendor neutral. We try to do our best to support all sorts of environments out there. We're not beholden to any particular type of operating system or hardware. We'll talk more about that later. And we also provide what we call an ecosystem. There are 75 plus companies involved in the development of these Edge solutions as part of what's known as the Linux Foundation Edge umbrella project. That ecosystem is out there to help you as well. So it's not only about developing the software, it's also about a group and a collection of companies and organizations helping to draw solutions together for Edge capability, for IoT capability that is meant to help you in your circumstance. It's a microservice, loosely coupled software framework for IoT and edge computing. What does that mean? We'll talk more about that here in a bit. Microservice architecture really lends itself to being flexible and adapting to all sorts of different situations and adding new components all the time, or replacing components with something maybe you want to create. As I mentioned already, we're hardware and OS agnostic. We run on ARM, we run on Intel, we run on Linux, Unix, Mac OS, Windows. We really are agnostic with regard to our approach and trying to assist all sorts of organizations get their edge solutions up and running in their environment, not having to change that. We are run by the Linux Foundation, and it's an Apache 2 project. What does that mean? Very business-friendly license, one whereby that you can take EdgeX, you can develop, you can even create a commercial product with EdgeX and never have to come back to or discuss it with the community. You can build your own adaptations of EdgeX, and again, never have to inform the community. Of course, we'd love to find out what you're doing, and we'd love to have you participate, but it really is a business-friendly license that allows you to take what you have and you see here today, march with it, create your own solutions, and do whatever you'd like with it. Again, the project started back in 2017. We took a couple of years at Dell to create it, and then we open sourced it through the Linux Foundation. And at the time of its origin, we had about 50 companies join with us to kind of host and support EdgeX. Today, that's up to about 75 organizations as a part of a bigger umbrella group inside Linux Foundation called LF Edge. Speak more about that as we go. Lastly, before I leave this slide, you see that there's a little character here on the screen. This is Edgy. He is our mascot. And a kind of an interesting little side story. The reason we chose Edgy, if you don't know a little bit about Octopi, Octopi actually have not only a central brain, but they also have kind of mini brains in all of their tentacles and their 8 arms, so to speak. And that's kind of how we envision the way EdgeX work. EdgeX is the little mini brain that you have out there at the edge of your network, at the edge of your existence of things, kind of pull in information and be your guide for things to happen out there at the edge. So Edgy, very much a character in our world of EdgeX, but also one that is very much associated to the types of things we're trying to do in EdgeX. So when I tell people what EdgeX is all about, the easiest way that I can describe EdgeX is that it's middleware, edge middleware. It sounds kind of bland when you say that, but really it's all about providing that connective tissue, that middleware between your operational technology world and your IT world. In most cases, from an IT perspective, we typically find applications, environments, hardware, networks, everything speaks TCP/IP. That's what makes communication in this layer pretty, let's call it simple from many respects. Not that building applications in your enterprise is always simple, but the communications therein is usually pretty straightforward. When it comes to the edge and operational technologies, some things in this area have been around for a long, long time. And these protocols and formats and the types of compute environments you find out there vastly different. Hundreds and thousands of protocol types out there, from things like Modbus built in 1979 all the way to some of the more modern protocols out there, things like Bluetooth and Zigbee, which are wireless. All those protocols out there at the edge in our OT environment, wanting to try and get data into our IT environment, to our enterprise, to our clouds. That's a difficult challenge. EdgeX provides that connective tissue, that middleware that is the go-between between your OT worlds and your IT worlds in both directions, allowing data to pass from these things to your enterprise and allowing your enterprise to communicate back down to a thing as if it was connected just as another TCP/IP type of piece of equipment. That's what EdgeX is all about. So hopefully today we're going to give you some insight into how that works and how we're able to make that happen, and also how to provide for additional capability here when your OT world doesn't maybe quite align with some of the OT worlds we've had to deal with in EdgeX before. So the tenets of EdgeX, what its architecture is based on, is first and foremost being platform agnostic, as I mentioned, both hardware and OS. But oh, by the way, also protocols. We deal with all sorts of the different OT protocols. And we also offer the ability to run EdgeX in distributed and all sorts of interesting deployment modes. We'll speak to that coming up as well. EdgeX Foundry is built to be extremely flexible. We believe in best of breed solutions. So if you have a replacement capability for one of our microservices, or if you think EdgeX would benefit from a different database, we've tried to outfit EdgeX to address all those types of needs. Now, EdgeX, the project itself, may not offer all of that capability, but the ability to bring your own, provide your best of breed solution is what EdgeX is all about. We actually encourage that. We know that we're not going to hit everything out of the park with what we call our reference implementation, at least not hit it out of the park for your particular use case and your circumstances. But EdgeX is flexible enough to adapt to your needs and allow you to plug in the modules you want without having to replace the entire system, or if you will, creating a new system from scratch. We'll tell you how that's done through our microservice architecture coming up in just a second. EdgeX provides for store and forward capability. What we mean by that is you have the ability with EdgeX to store data at the edge for a considerable amount of time, and then when things get reconnected from the edge, be able to move that data off back into your enterprise. This is critical for use cases that maybe, say, for example, on transportation equipment like a barge or a rail car, where it's in and out of connectivity. It's also important because you may need some of that data at the edge when you're making some sort of intelligent guesses or analysis on what needs to happen at the edge. I give an example with people all the time where if you were to fire your airbag in your car from a decision that is made in the cloud, that probably is going to be a bit dangerous. There are lots of times when the decision has to be done at the edge where you want the data at the edge to be able to make that decision. And that's why store and forward is important. We facilitate intelligence moving closer and closer to the edge. EdgeX comes with a reference implementation rules engine, but you could add your own, for example, artificial intelligence. And we'll again talk about that and its flexibility. You can provide for better actuation with very low latency concerns, avoid having to send all the data back into the back end, and avoid costs associated with that bandwidth and storage, and also operating remotely with regard to connection and disconnection, and being able to essentially run intelligence without all of those interruptions out there. EdgeX is all about that. We support brownfield and greenfield device and sensors. You don't have to bring everything anew into an EdgeX environment. In fact, we adapt to most of the types of things that you already have in your environment. And we provide for a secure and easy means to manage EdgeX. So these are the tenets I hope you'll see as we start to talk about the architecture and as you see EdgeX working today. Now, how does it work? Well, it's a collection of microservices I mentioned. Most of those services today are written in Go and C. We've got things like UIs written in JavaScript. So we're polyglot believers, and we believe that if you have a particular language or technology of choice you want to bring to EdgeX, you can do that. Again, that might be something you do versus the community, but we're very flexible in regards to what types of technology are used in the microservice collection. The data flow I'm going to explain here in just a bit with a diagram and a series of kind of annotations to see how this works. So I'll come back to that in a second. Most of the microservices we have a REST API that allow you to perform operations, check on the status of those services, and get information out of the services for whatever that service does. But we also support data flow from south, which we consider to be the sensors and devices, to north and back again via message bus or REST. So you have a couple different options here when communicating with EdgeX. Now, the project, as I mentioned, does provide some pre-assembled artifacts for ease in your deployment orchestration. So we provide Docker images and Docker Compose files. We also have snaps, which I mentioned will be part of a discussion coming up in another tech talk. We also provide things like Helm charts if you're an organization that is found using Kubernetes to be an option you want to explore at the edge. So we provide a lot of artifacts to help you get going, But you don't have to use those. You can run EdgeX right on what we call native or bare metal types of circumstances. Those circumstances may be something you have to do a little bit of work to get up and running, but we do provide the raw code for which you can then go out and actually get EdgeX running in whatever environment you have. Okay, so let's talk a little bit more about the architecture and how EdgeX works. What you see represented here on the screen is EdgeX Foundry and all of its microservices. All of the little boxes you see represented on the screen, the little black boxes, and let me get my pen ready here to start writing some things. So anything where you see a little box here, like in this case, eKuiper, that is a microservice or a service as part of EdgeX Foundry. When we look at and address EdgeX Foundry as a collection of microservices, we usually describe it with regard to, that is with the services, with regard to where they sit in the architecture. Starting at what we call the south side, these are devices and sensors you may have in your environment that you want to communicate with and get the data from those sensors up into your enterprise. So south side is always what we represent as the sensors or devices in your world. Whereas the north side is what we consider to be your enterprise, your cloud environments, maybe your applications or your databases that typically reside inside of things like your command and control server environments. The task of EdgeX is to serve as a go-between between these two worlds, the south and the north, with this collection of microservices. Now, the representation of the services you see here on the screen, all these are available, but you don't have to use all of them at any one time. In fact, most organizations will pick and choose the services they need in order to be able to operate for their use case. So let's see a little bit about how EdgeX works, and then you'll start to understand too where some of the picking and choosing of those services is going to be relevant. First and foremost, EdgeX provides what's called a collection of device services. These services physically communicate with the sensors and devices in your world. So let's say we had, for example, some sort of a temperature sensor out there, then that temperature sensor would speak a particular protocol with one of our device services. In this example, let's just say that the service speaks CoAP and is communicating with some sort of temperature sensor via CoAP, and it's getting readings and sensor environment information from that particular piece of equipment. In this case, the temperature is 102 degrees Fahrenheit. Device services job is to read and communicate with those things. Once it's got information from those things, its job is to then communicate that up to what we call our application services. We'll speak more about what application services do here in just a bit. Simultaneously, however, and optionally, those device services can also send the data into a service we call core data. Core data's job is to make the data available in a persistent store for a certain period of time. If you will, it's the local persistence offered by EdgeX that I mentioned before. It's what allows that data to be used at the edge for whatever means you have. It also allows that data to be stored and then later forwarded when things are reconnected from the edge to your enterprise. So in this case, our device service is sending data into an application service layer and simultaneously and optionally sending it into core services where it can be persisted. By the way, when core services is connected, that data can also be further directed back to application services. You may want that in cases where, say, for example, that application service needs to go back and understand more about that history or the data that's available from the perspective of that persistence. Now, once the application services have that data, what do they do with it? Well, an application service has many tasks. In many cases, what an application service is going to do, it's going to prepare that data for a ride to the north. It's going to prepare that data to export it to your cloud, your enterprise, your on-prem situation. We provide a set of application services with all sorts of what we'll call connectors to deal with all the various clouds, AWS, Azure, Google. Also being able to send that data just by simple MQTT or REST. Any type of protocol you could think about, application services can be made to make that data available over the protocol of choice in your IT environments, typically some sort of TCP IP-based communication channel. Oh, by the way, it will also format data to whatever you need. It can put it in XML or can put it in JSON. It can filter out what data you may not find to be relevant. It can also compress and encrypt that data. Application services essentially serve as kind of an enterprise application integration engine for getting the data when, where, and how you need it into your IT world. Application services, though, have a second job. Their second job is to prepare that data so that it can send it into whatever analytics, whatever local intelligence you have at the edge. Now, EdgeX provides by default a simple rules engine. Another sister project within LF Edge is called eKuiper. And that rules engine, SQL based, allows for EdgeX to inspect data that it's collecting from the edge and make decisions on it based on kind of if then else rules. And in this case, eKuiper could be looking at the data and it could be looking at things like temperatures. And if it determines that maybe a temperature is getting a little bit too hot, it can send that information down to another service within inside of EdgeX called Command. And Command's job is to communicate back down through device services to actually actuate back down to the edge. In this case, maybe using another protocol device service, and Modbus, for example, to tell some machine to turn off because the environment is too hot. So this round trip of collecting sensor data, making it available both to your enterprise, but at the same time making it available locally to any kind of analytics package so that things can be actuated is what EdgeX is all about. The other services you see here on the screen are really there to help support in that whole, if you will, mission. Scheduling, alerts and notification, there to help trigger things on certain timeframes and or to let people know that something else is out of alignment and maybe to let the human user know that some other action may need to be taken care of. Things like security services, system management services are there to support, if you will, the overall deployment orchestration, management, and security of EdgeX and all of its services. I'm going to draw attention to two things before I leave this slide. You'll notice that EdgeX provides for two SDKs, one at the device service layer, one at the application services layer, and those are there to help you create your own points of contact with either things in a device service case or your IT environments, your enterprise environments in the application service case, when EdgeX doesn't have it out of the box. We provide a lot of capability out of the box, but those two SDKs allow you to create your own capability when EdgeX itself doesn't have it at the ready supply. We've got tech talks coming up on both those subjects, how to create your own application service, how to create your own device service in June. So stay tuned and come back for more. So key services within inside of EdgeX. Device services, again, this is what provides your means to communicate with things in a protocol of that thing. So Modbus, BACnet, BLE, whatever the case might be. And again, SDK there to help create your own solutions, your own device services when EdgeX doesn't provide them out of the box. By the way, one thing we will see here in the demo of EdgeX and getting it up and running here is something we call a virtual device service. When you're just getting started with EdgeX, if you don't have a particular thing, a sensor or device to connect to EdgeX, we provide a virtual device to help simulate any kind of data that you'd like at the edge. So we can simulate something like a thermostat producing temperature data. Whatever you'd like it to do, it can generate integers, floats, strings, booleans. It helps to serve as a sensor simulator, if you will, in environments where you're just getting EdgeX up and running and when you're trying to get all the pieces functioning. Application services, as mentioned, this is where you use EdgeX service to get data to your enterprise, whatever that enterprise might be. Cloud system, data lake, application, whatever the case might be. And it helps to filter, transform, encrypt, compress, whatever means you need of having that data arrive at your doorstep in your IT environment. Application services can do that. By the way, we provide a configurable app service out of the box, one that provides most of the capability of all application services needs that we see, allowing you really to do more of configure versus coding if you have relatively straightforward needs in this application service area. Again, an SDK there to help create new ones where you don't have, where you have a need, I should say, that's outlying of what EdgeX provides out of the box. Some other key services here, you already saw core data, where it provides for persistence of things like sensor data at the edge. Core command serves as a means of proxying. So between the intelligence and actual device services and devices, it sends actuation requests down to the devices and the sensors so that you don't have to speak the protocol of any one sensor. Command will take care of that through the abstraction of our service layer and of knowing how the protocols at the edge work. One last service that we didn't really cover in my diagram is something called core metadata. Core metadata is a service that knows about what's connected at the edge. what device services are managing what's connected, how to communicate with them, what type of data do they offer. As the name here, metadata, implies, it is the service that knows all about what's connected to the south side and can make that information available to other EdgeX services or to your other applications, to things at the north, things that may need to know what is connected and how do I communicate with it. There are a lot of third-party components within EdgeX. As an open source project, we believe in using a lot of open source technology to deliver our solution. So from a database perspective, when we talked about core data and having the ability to persist sensor data at the edge, how's that accomplished? Well, core data underneath the covers is actually working with the Redis database. So a nice NoSQL solution here to store and collect the data at the edge when desired. By the way, Redis also offers a message bus as part of its capabilities, and we actually use that by default inside of EdgeX when messaging between services, something that you may not be aware of when you're just seeing all the data fly around. But EdgeX is actually using a message bus technology in many cases to communicate. We use console as the means to register all those microservices and to serve as a store for configuration for all the services. Configuration being information about, for example, what port a service operates on, or whether certain features like, for example, the ability to have data stored at the edge, all of that's configured and stored in a configuration service that is a nice, easy, convenient way for you to make changes to your environment when you need to. We use eKuiper, a sister project inside of LF-Edge, as our reference implementation rules engine. You may want other intelligence at the edge. You may want to put something like AI ML at the edge. You can certainly do so, but out of the box, EdgeX provides a nice SQL-based rules engine for you to trigger these kinds of actuations. And on a security side, we use Kong as our API gateway to protect all of the REST communication. And we use Vault as the secret store underneath the covers. So if you have something like a certificate or a username and password that's needed to connect to a certain piece of equipment and or to connect to, say, maybe your enterprise, that's all stored in Vault at the edge. Now, EdgeX, as I've described it, kind of looks like it all fits in one box. And that typically is the way we think about EdgeX, as an application, a collection of microservices running on one platform. But that's really just for simplicity's sake, being able to describe EdgeX. In reality, you're going to want EdgeX to lay on top of whatever type of compute, storage, and network resources you have available. So there are cases out there where people will take the microservices and actually deploy them across a whole host of environments. In some cases, running, for example, a device service right on a piece of equipment, a device or a sensor that has compute power, and then maybe putting the other services on something like an IoT gateway. Others still may run things like some of the more intelligence operating services like the analytics in the actual cloud. EdgeX doesn't care. You can choose to run EdgeX however you see fit, distributing those services across whatever type of environment you have. Now, there's some complexity with that. Obviously, you have to configure to make sure all the services can talk to each other. And in some cases where the security between the various pipes is of utmost importance, you're going to have to obviously put in place things like TLS and other security apparatus to secure that communication. But EdgeX as a collection of services is able to operate over whatever type of tiered deployment you so choose. So while I'm explaining, and I'll demonstrate today EdgeX all running on one box, do be aware that EdgeX is capable of operating on top of your entire fog deployment as your use case dictates. Okay, time now to start to learn a little bit about how EdgeX actually operates to see it running. When we come to this point in the discussion, we have to talk a little bit about what is your goal with looking at EdgeX. Do you want to use EdgeX, but not necessarily change it, right? I want to be what we call a user or adopter of EdgeX, where I want to grab EdgeX and I want to create an IoT or edge solution, but I don't really have the intention of making any kind of major changes to EdgeX. You want to connect your things, certainly. You want to get the data from your things back into your back-end enterprise. You may actually want to do some actuation with the data coming out of your things, but you don't intend to make all sorts of changes to EdgeX and its host code. In this case, you want to consider yourself an adopter or a user. You're going to use the containers or snaps that EdgeX provides, and that's what's going to be highlighted in today's demonstration. Now, maybe you'd like to join the EdgeX project. Maybe you'd actually like to start to significantly modify our platform, add new ingredients to it that we've never considered. Or maybe you're the type of organization, you work for a company that's going to use EdgeX as the base platform, but you intend to make some significant changes, change how EdgeX maybe fundamentally works, or add all sorts of new ingredients. You want to start working with EdgeX code from scratch. Then you're considered what we are calling a developer in the EdgeX world. Now, that's a path that we'll have a future talk on, but that's going to require obviously a little bit more work, but you'll start to get a little bit of appreciation of how that might work today, just as we start to explore all of the services and how they work together. And importantly, you might also discover that you don't need to do this for every service. You may be what we call a hybrid user, which means that you want to run most of EdgeX out of the box, but then you may want to add, let's say, a new device service, or maybe make a minor change to a particular service. So you're not intending to get in there and muck with all of EdgeX. You want to start to add little pieces or make small changes, in which case you can run EdgeX as it stands with its containers and snaps as they are today, and then add a couple of tweaks in this hybrid form where maybe most of EdgeX is running in its containerized form, and then one service or two that you're working on is running natively. That's something you'll also gain a little bit of appreciation today, although it'll be covered in an upcoming tech talk. You'll gain a little bit of appreciation of today just based on how EdgeX works from the standpoint of a user or adopter. So as I mentioned, the path that we're going to really focus on today is this adopter path. But knowing the adopter path is always where I tell people to start, even if you're going to be a huge developer of EdgeX, or even if you're starting to be what we call a hybrid user with doing some development and using some of EdgeX out of the box. Getting a first start at just how EdgeX operates, how it runs, how you get it up and running is your first step and what we cover here today. Now, I did have a question come in from Justin who says, is there any management for rolling out OTA updates or use, for example, the Gateway's Linux software and kernel to be able to, I assume, manage and run EdgeX? And the answer to that is there are some things out there, Justin, that we do provide, and we'll talk a little bit about that. But I'm also going to give you some tips and tricks, in particular using some tools that we find is very helpful out there, not necessarily provided by the project, but what the project uses a lot in order to be able to both manage and understand. And you'll also see that we can use things like Docker Compose here in just a bit to orchestrate and get the software out to a Linux platform, for example. So great question. Thanks, Justin. All right, with an understanding of the paths and what types of development you can do, let's start to actually get working here. For an adopter, what an adopter is going to do is they're going to do what we call pull and run EdgeX using Docker containers or snaps. Now, again, snaps is going to be covered in a tech talk coming up in the future. We'll cover doing it with Docker containers today. You may make some small changes, but this is usually with configuration, if you will, low code or no code in terms of how we actually start to explore the changes in EdgeX. For example, if you need to add a rule to the rules engine, you could do that without having to do any new code. You just have to add either some configuration or make a tweak through a user interface to those rules. So it typically doesn't require any coding, doesn't require any building of the microservices, just pull and run them. Hybrid users are going to do some of the same thing. They'll still pull and run, but then they may actually make some small changes or add new services, as I mentioned. Again, this is a future tech talk topic. And developers, they're going to want to actually download all of the code and build everything from scratch. This again is also part of our tech talk series in the future, but it is one that goes in much more depth with working with actual hands-on code. So it really requires a bit more, let's call it engineering expertise, but one that is not certainly out of the realm. And we try to make that as easy as possible. And on June 28th, as I did mention already, we'll have a talk from the folks at Canonical on how you actually pull down and use snaps versus Docker containers if you choose to be an adopter in this realm. So if you are an adopter, what do you need? Well, you need some tools. You're going to need a host platform. Now, ideally, you want that platform to have about a gig of memory and about 32 gigs of storage. Yes, you could probably actually get away with a little bit less. You will find that you don't need all the EdgeX services. You'll find that you may not need all that storage because you're not intending to store a lot of data at the edge. So you can get away with less, but we always tell people that's a starting point. Then let your use case and your experience help dictate where you go from there. Now we support all of the major hardware platforms again, x86, x86 64-bit, ARM 64, Linux, Mac OS, you name it. What you don't see here is ARM 32. You can, and we have seen people build a lot of EdgeX for ARM32 platforms. It's just not something from an adopter standpoint we support out of the box. That's going to require you to do a little bit more work. There is a document out there about how you can actually get EdgeX up and running in this environment, but it does take more work on your part to run an ARM32. If you want more details on the platform requirements, you can see a link here to our docs. I'll actually bring up our EdgeX docs here in a little bit, and you can see that there is all sorts of information out there to include platform requirements. In addition to the host platform, what else do you need? Well, you're going to need Docker and Docker Compose. If you are going to be using the Docker containers, you need to be able to have the engine to run those. And you need some sort of editor just for making small text changes in things like a configuration file. You'll need a browser to be able to access the user interfaces of EdgeX, which we'll see. And you'll need some sort of tool to make REST calls. I like something as simple as curl, which you'll see in the exploration today. But if you're a fan of something like Postman or some other more industrial strength REST calling tool, then have at. It should work with EdgeX because we use standard REST type of calls out of the box. The getting started guide in our documentation is going to cover a lot of what I'm actually going to talk to you about here and show you in the next few minutes. So if you're missing pieces or if you're finding some of what I have to say a little bit confusing, rest assured the docs will help back up what I'm saying and provide you even more details than what we have time for in our tech talk today. So getting started as an adopter, as a user of EdgeX, as I mentioned, the first job is you've got to pull and then start up or run EdgeX. The first thing you need to be able to pull EdgeX in all of its Docker containers for all those microservices is what's known as a Docker Compose file. Docker Compose is a technology which it says, it's a manifest, if you will. It says, here are all the Docker containers that I want to work with, and here's how I want to get them started. EdgeX provides a collection of Docker Compose files for all sorts of circumstances by which you want to run EdgeX and for all the various versions. If you go to bit.ly EdgeX latest, you'll find the latest Docker Compose file, the one that you'll use for the version we have out today, which is called Kamakura. If you want to see all of the Compose files, all the options, if you will, to look at all the various versions and or all the various types of configurations for EdgeX microservices being up and running, you could take a look at EdgeX Compose to see all of those at that bit.ly address. I'll take a look at these here in just a second and we'll see what's available. But I always tell people, start simple and move from there. In this case, start with the latest, get all of EdgeX up and running, and then you can start to play with other versions and or you can play with the latest code and or you can play with other types of environments that may include things like the security elements. So how do you download and get this Docker Compose file and thereby download and run EdgeX? Well, use your favorite tool. In my case, I'm going to use curl, as we'll see here in a second, but you again use any type of HTTP REST recalling type of apparatus to pull down the Docker Compose file from our GitHub address. We'll see that here in just a second. Once I've pulled down the Docker Compose file, I will use a Docker Compose command called up to actually bring all of the EdgeX Docker containers into existence on my machine and start them running. And once I have them running, I can actually check that with a Docker Compose PS command for process stat. Is everything up and running, and can I see that it's all operating correctly? By the way, for those who know a little bit about Docker Compose, no, there's not a typo here. In the previous versions of Docker Compose, you had Docker-Compose was the command. With version 2, they've since removed that little dash. And for those of us who've been around a while, it's terribly frustrating to keep forgetting that and then finding out, oh yeah, I keep forgetting to remove that dash. So for those who are new to Docker Compose, don't worry about it. It's just Docker space Compose. For those who are old, it's not a typo. The new version of Docker Compose removes the dash. We'll see that here coming up in just a second. Finally, what we will see that EdgeX consists again of all sorts of microservices. We're going to be playing today, and what is provided out of the box with our latest versions of the Docker Compose file, a virtual device service to simulate sensor data. You won't run that probably in any kind of production environment, but to get things up and running very quickly, as you'll see, This is already provided with the Docker containers that EdgeX provides out of the box. It also provides a rules engine to trigger things, but with no rules. So we'll actually take a look at data coming from this virtual device service so you get a sense of how things work and flow in EdgeX. And we'll actually write a rule so you can start to appreciate how the rules engine can be used to trigger all sorts of actuation. So we will provide a complete guide of getting things up and running. And from there, you can start to experiment as your use case dictates with elements that you're going to either add, remove, change, what have you. So let me bring up real quickly here. I've got a Linux environment. In fact, this is Ubuntu 20.04 version of Linux on this box. And just for example's sake, I mentioned that we like to tell people start with a gig of memory and about 32 gigs of disk space. And you can see here, that's about what I've got on this box, about a gig of RAM and about 32 gigs of storage. So nothing huge. And yes, it could be smaller. But experiment with that and see where you can kind of turn things down and where services you may be able to eliminate before you start to go a lot smaller, just so you know you have enough room to run your EdgeX environment for your use case. So the first task, again, we have is trying to get the Docker Compose file we're going to use to pull and run EdgeX. Now, from the bit.ly addresses I mentioned, if you go to bit.ly/EdgeX latest, that will take you to the latest version of EdgeX Compose files in our EdgeX Foundry GitHub repository. Kamakura version 2.2 is our latest version, and you can see there are other versions out there. But if you're going to the latest, you're going to be downloading a Docker Compose file from this GitHub repository. Now, there are lots of options here. You can get Docker Compose that is for ARM64. You can get Docker Compose with or without security. You can get a Docker Compose file for your environment. I'm going to start with very simple Docker Compose environment. That is, I'm going to start with Docker Compose without all the security elements and one that's outfitted for an Intel platform. If it says ARM64, that's what's your indication that it's ARM ready. Otherwise, it's for an Intel platform. So ordinarily, you would go to this particular file and you would pull down this Docker Compose file into your environment so that you could then bring EdgeX up and ready to go. By the way, when you do that, don't just copy from this page. You want to go to the raw setting, because otherwise, if you copy from here, you're actually going to get a lot of HTML things that you don't want. So I always tell people, go to the raw, copy the Docker Compose file you want to use to get EdgeX up and running for the version, for all the apparatus that you want. That's what you do to get EdgeX up and running. So from my environment, I'm going to do that with a simple curl command. That file that we just looked at, the Kamakura version, I'm going to ask my Linux environment here to curl that Kamakura Docker Compose no security file, deposit that in a file here right in my local system called Docker Compose YAML. Docker Compose is made up of YAML. And if we do a more on Docker Compose YAML, we can see that now, the same code that I just showed you via GitHub. So now I've got the manifest file. I've got all the ingredients ready to actually pull all the Docker containers and run it. So how do I do that? Very simply, Docker Compose up/d. The -d says do this as a daemon so that it's not going to be spitting out all the logs and staying right here in my terminal. It's going to actually launch a daemon to pull all these containers and start them running. You can see here in my Ubuntu environment, Docker Compose is now doing its job of pulling everything and starting to actually run things. I'm getting a request from one of the folks here online if I can make my screen a little bit bigger. Let me see if I can do that. Sorry, everybody, for the small screen. Text here. Let's go with, well, it's not going to help us. Where's the, there we go. Hopefully that's a little bit better. Okay, so now I have pulled all the Docker containers using a Docker Compose file and started them. How do I know? Well, there's a Docker Compose command called PS that I can run, and that will actually show now. Let me make this full screen since it's tough to see now. It'll actually show all of my Docker containers for EdgeX up and running. And you can see all the names we talked about as we did our architecture review. There's core data, there's core metadata, there's the device virtual service, there's eKuiper. So all those services that are part of EdgeX are now up and running and available to me. How can I test to make sure that's actually the case? Well, each service comes with what we call a ping REST API. Ping is just a means to hit that service and get back a signal from it that is up and running. So for example, I could ping core data or core metadata or a virtual device service. How do I do that? There's an API document that we'll take a look at here coming up shortly. But if I make another curl request, I can ask to curl at the address and the port of any one of the services, API v2 ping. It's just a ping address. And what I get back is an indication from that service that it's actually up and running. In this case, responding with the core data name saying, yep, I'm running. I could do the same thing with, say, metadata. So let me change my address to, oops, making mistakes here. Everybody gets to see Jim be a miserable typer. 59881 is the port for metadata. And there I get back an indication that core metadata is all operational. So not only did Docker Compose tell me that my services are up and running, but all of my pings are able to tell me that my services are up and running. Now, if you're running, how do I find out all of those, say, particular API ports that you just found there, Jim? Well, if we go out to, whoops, my documentation page here, let me pull that up. docs.edgexfoundry.org. You'll see this is the documentation for EdgeX, and again, it's based on a particular version. I'm looking at the latest, the Kamakura documentation. And if you pick on reference, you can see there's the platform requirements documentation, but there's also this default service ports. And this gives you a listing of all the services in EdgeX and what their default port is. So 59880 is for core data, 59881 is for core meta, and all of the other services to include things like device virtual are there as well. So you can use this page to go ping any one of the services and make sure it's up. Or again, simply do a Docker Compose PS, and that'll essentially tell you that everything is up and running as well. So fantastic. Now we have EdgeX up and running. Well, thanks everybody. Thanks for coming. No, not really. I know there's still more to learn, but at least you can see getting EdgeX, getting it up and running is actually a pretty straightforward exercise. Now, once we have it up and running, we want to start to see data flowing through EdgeX from south to north, so to speak. We want to understand how to be able to make changes. We want to be able to explore some of the APIs. We want to be able to troubleshoot EdgeX. How do we do some of those things? Well, the very first thing I'm going to teach you is that EdgeX comes with a little user interface. This is a fairly simple user interface, but one that's very helpful as you're getting it going in EdgeX. How do I actually see the user interface and see what's happening inside of EdgeX? Well, if I bring up any kind of browser and I go out to the browser and I hit address, I'm looking for my browser page here. There we go. If I hit the IP address of my host box at port 4000, which is where the UI runs, I'll come in contact with a page that looks just like, and I'll give it a second to refresh and display here, just like what you're about to see on the screen. What does this page tell me? Well, first off, the front cover of the UI gives us a dashboard. What services are up and running? For example, we've got 2 device services and all of our other services are up and running. It tells us how many devices, physical sensors, or things are connected. If I page down through the rest of the system, I can get some system information and an ability to actually start and stop my services. Metadata, as I mentioned, tells you what things are connected and how to communicate with them. So I have at my disposal through this UI an ability to actually go in and see what's happening inside of EdgeX and potentially make some changes. Through the Data Center tab, I can actually see the data flowing from the device services all the way up through to application services. So I've asked it to start displaying kind of as a free flow of stream information here. And you can actually see the JSON data coming in from all of my devices, giving me what are called events and readings in the EdgeX vernacular. Readings are just key value pairs for the data that's being collected by a sensor. In this particular case, it's collecting a random float piece of information that's telling me the value for that random float is whatever you see there on the screen. Now you might be asking, well, where is it picking up this sensors, these devices? Recall that I said that one of our device services is a virtual device. And that virtual device mimics or simulates all sorts of device data. In fact, as we see here through the user interface, it will simulate a random unsigned integer. It will send out signals from a random float. Again, all of these things are configurable, but essentially sends out data as if data was coming from some sort of sensor device, creating this kind of information. So that's what we see in the data center. We actually see the data coming from that device virtual in all sorts of forms based on the types of mimicked sensors it's trying to produce. Great. So now we've seen a little bit about how to inspect EdgeX, the services that are running, the data coming through EdgeX. Obviously, if you connect your own devices and sensors, as you'll learn in future tech talks, you would actually see those sensors or devices and their data coming through in this same user interface. Now, EdgeX comes with each service comes an API set that allows you from an application standpoint to call into EdgeX and get more information. For example, we can call on core data. The core data service has an API set that allows me to get back information like events or readings from the core data database. I can find out how many events are actually in EdgeX. It's stored in the database at any one time. I can find out, if there's a device out there, what some of its more recent readings are. So I have at my disposal a whole API set to go out and trigger all sorts of things on EdgeX to either pull back information or make things happen. Let's go out and experiment with that a little bit. Let's actually go out and ask to run one of these APIs. Using curl again, I'm going to ask core data, which is a service at 59880. That's its port. In fact, you can see that in the Docker Compose status there. So I'm going to call on core data and ask it to give me the event count. So this is actually hitting on one of those REST APIs that EdgeX offers. And at this point in time, it tells me that EdgeX has created or collected 304 events for all of that device virtual that's connected right now. There are all sorts of other APIs out there. If I wanted to call on EdgeX and call on core metadata, I could call using an API, core metadata, which is at 59881, and get all devices that are currently connected. It will come back with a collection of JSON data that might be a little bit hard to see and understand at initial bluster, but really what this is just JSON data describing all the various devices that are connected, in this case our virtual device, and the types of information that those devices and sensors provide. This allows me to communicate with those devices and sensors later on as I start to learn how to actuate, or if I learn how to start to use a rules engine to trigger things that are going on. So the ability to communicate via REST APIs as well as the user interface is what's key to starting to work within EdgeX. Okay, so now we've learned a little bit about the user interface. We've learned a little bit about how to communicate with it. How do I start to do some more advanced things? Like how do I start to troubleshoot? For example, let me bring back up my slides. What if I wanted to understand a little bit more because I'm starting to see that the ping checks in the UI and the API exploration is starting to identify problems out there. How do I troubleshoot some of my EdgeX environment? Well, the thing you're going to first come in contact with is the fact that in many ways, our Docker containers are really helpful in making EdgeX get up and running very, very quickly. But there's also a bit of an issue in that right now, it's kind of locked down. It doesn't allow us easy access outside of the box that we're working on. In this case, if I'm working on this box and I'm dealing with localhost, it allows me to communicate with it. But if I'm not, one of the things I learned very, very quickly is that if I try to, for example, let me go back to my API here. If I try to hit that box and do a ping test, for example, off box, not on that box, you'll see that it's unable to connect. So one of the very first troubleshooting things I tell people is you're going to have to start to loosen some of the constraints of EdgeX just a bit in order for that communication to start to occur. How do I do that? Well, I do that in going in and taking a look at the Docker Compose file and loosening up the restrictions there, and that in Docker Compose right now, the communication with EdgeX is all restricted to the local host. Every place you see 127.0.0.1 in the Docker Compose files telling EdgeX only allow the local host at this address to communicate with my services. So one of the very first things that we have to do in order to be able to communicate more directly with those services and start to understand things like logs and other things that are out there in the environment to troubleshoot is to loosen up those restrictions. So what I'm going to do is take my Docker Compose file and I'm going to make a slight change. I'm going to ask it to change all the 127.0.0.1 addresses, and I'm going to remove all those. Whoops, made a mistake, didn't I? Let's see, 127.0.0.1 colon. This is why we make copies. Hang on, everybody. So I'm going to move a copy that I have Docker Compose already changed there, and I'm going to move that Docker Compose copied file to Docker Compose YAML. So just overriding, and that's going to loosen up that restriction. If I could type right. Now, if I do Docker Compose up again, it's going to run EdgeX just as it was before, but this time it's going to take away all those restrictions. And now I can start to diagnose and inspect and deal with EdgeX even off the box and get a little bit more details. So that's an important tip and trick as we look at EdgeX, as we start to explore troubleshooting types of techniques. So now, if I go back to my browser, and now I try to hit that same ping address as before, now I'm actually able off box to communicate with all of my services because those restrictions are loosened. Now, why is that important? Well, once I have things loosened up there a little bit too, I can also do things like use something like Portainer to start to diagnose and work with EdgeX. So I can bring in a Portainer tool and have access to all of EdgeX and all of its servers. I could start to use Portainer, a very important and valuable tool in the Docker community for looking in, inspecting the log files inside of EdgeX, or dealing with the metrics of EdgeX services. So somebody was asking a question earlier, how can I manage EdgeX? Well, this is one of the ways. You could start to use other tools that you'll find out there in the world to inspect Docker running type environments to go in and inspect that kind of capability. I can also start to look at things like the log files that are available inside of EdgeX from off box and pull those down. If we look at any one service, let me bring back here my services. If I look at any one service, we'll see that each one provides a log file. So I can ask for a log by doing a Docker Compose, let's say, trying to think of a good service here to give us some sort of log information here. Logs, data. And I'm going to put a tail on that just so I can see some of it. Whoops, mistyped again. And so now we see a log file from our core data service. We can use those log files to start to inspect and get an appreciation of what's going on in EdgeX as well. So some tools and some tips and tricks about how you can start to explore, diagnose, and troubleshoot EdgeX. More of this information will be available on the wiki along with the slides today. I'm starting to run out of time, so I want to come back and just give you some resources that you're going to want to take a look at in addition to what I've covered here today. So we pull in here now some resources you can look at. We've got docs, which I've taken a look at, docs.edgexfoundry.org. We've got a Slack channel where people will answer questions you have about your environment. Take a look at the general channel as your first starting point when you ask a question of the EdgeX community. The YouTube channel will contain this presentation today, but it has all sorts of other introductory presentations, and you can find that at our EdgeX YouTube channel, or just search for EdgeX Foundry on YouTube. If you want the code, go to github.com, EdgeX Foundry, and then we're also on all the social media sites as well. These are usually not places to go and ask lots of questions of the EdgeX community, but if you are trying to find out what event EdgeX is going to be at or what's happening in the community, great place to learn more. Ladies and gentlemen, I'm out of time here for today, but again, thank you so much for being with us. And again, come back and join us on June 7th. That's next week, same time, as Lenny Goodell from our application service work group is going to show us a little bit about how to build a custom app service. And then as you can see on future Tuesdays this month, we have other talks that will cover more of the topics which I highlighted today. With that, I want to thank everybody for your time. Really appreciate everybody coming out and joining us here today. Again, if you have an idea for a new tech talk in the future, please do go ahead and send us a note. You can reach us at info@edgexfoundry.com. And with that, I know some people might have to head off, but I'm happy to stay for a couple of minutes and address questions you might have. I do have a question from somebody online too that says, are you planning to officially support EdgeX on top of, say, Eve or Open Horizon? And indeed, with Open Horizon, we already actually are working with that project in an offshoot of EdgeX called Aura. And if you want some help on that, just go out and search for the Open Retail Reference Architecture in LF-Edge, and you'll see EdgeX is already working with Open Horizon. We haven't had a chance yet to actually work directly with the Eve project, but it is on our roadmap and something we plan to do here in the near future. So thanks so much for your question, Carlos. Any other questions before we head out today? And I'm checking quickly to see if I've got any Q&A that I might have missed inside of our chat channels here. I don't see anything. I think that pretty much is it. Again, thanks everybody for your time. If you do have additional questions, send us a message, info@edgexfoundry.com. Actually, my apologies, edgexfoundry.org. Big typo there, everybody. Sorry about that. Got to remember to use the org, not com here, edgexfoundry.org, but send us a note at edgexfoundry.org. Happy to try to address other questions there. Thanks, everybody. Have a good day.